First speaker, Dr. Arlo Moehlenpah.
Thank you, Natasha. It's a pleasure to be here, and thank you for coming. The debate subject, I don't believe she read, but the debate subject that I was given was the following. The first topic is the theory of evolution is not scientific. The second is that the theory of evolution contradicts established scientific laws. And the third is that the theory of evolution is, for all practical purposes, mathematically impossible. Now, I really would probably call this 30-minute presentation Science versus Evolution. I think we need to define, first of all, what evolution is. I will read a definition that I found. It says, the evolutionary system attempts to explain the origin, development, and meaning of all things in terms of natural laws and processes which operate today as they have in the past. No extraneous processes requiring the special activity of an external agent or creator are permitted. Now, in addition to that, the theory says that particles evolved into elements, elements into complex chemicals into simple living systems, and simple living systems evolved into complex life, complex animal life into man by means of the properties of material itself. Now, assumptions are made in the evolutionary theory. They are the following: that non-living material gave rise to living material. Also, that single-celled organisms gave rise to multi-celled organisms. That invertebrates, creatures without backbones, gave rise to vertebrates. Fish gave rise to amphibian. Amphibian evolved into reptiles. Reptiles formed eventually birds and mammals. These are the evolutionary assumptions. Now let's talk about science. What is science? Well, first of all, if you go to a dictionary and look up a definition of science or other sources, I will not bore you with a long dictionary definition, but I'll give you some key words. If it's scientific, it's observable. If it's scientific, it needs to be subject to some kind of experimentation. If it's scientific, you ought to be able to verify it. In other words, if I discover something in San Diego, you ought to, with the same equipment, be able to verify it and repeat it here in Tampa, Florida. Okay? I'm here to say that the theory of evolution has never been observed. Never has a fish been observed to change into an amphibian. Never has an experiment been performed to do this. It cannot be verified, and it has never been repeated. Thus, the theory of evolution is not scientific by any of these four words or definitions. Now let's talk about the steps in the scientific method. The steps in the scientific method are, first of all, you have some sort of a problem or question. For example, I have 3 balls here. I have a ball. What is this? Golf ball. The yellow one is what? Ping pong ball. And anybody know what the white one is? Wiffle ball. Now, the problem, I'll give you this as an illustration of the steps in the scientific method. The problem is if I drop these 3 balls, which will hit the floor first? That's the problem. Now, the young lady in the front gave a hypothesis. That's an educated guess. She said the golf ball would hit first. What are some other hypotheses? They could all hit at the same time. What? The heaviest one hit first. Okay, was I already put there that it all hit the same time? I guess another hypothesis is it wouldn't drop at all. Another hypothesis would be that it would go upward. Well, those might not be very good ones. But hypotheses is some kind of a guess that then we can test. Okay. Now, many means of solving problems, we solve the democratic method. In other words, we would vote. And let's say, I'm not going to take the time, but let's say I would vote. Say how many believe the golf ball will hit first? How many believe the ping pong? How many believe the wiffle ball? How many believe they hit at the same time? Well, if we took a vote and the majority was one thing, then it's over the democratic method. Okay? I believe the democratic method, good method to solve political problems. Okay. But the scientific method differs. Scientific method would be a controlled experiment. In other words, we don't just vote on it. We actually drop them and see which one hits first. Now, my purpose today is not for you to know which one hits first. I want to show you what the scientific method is. Okay, then you would correlate the data. If we really had a sophisticated experiment, we'd probably measure the temperature of the air, the barometric pressure, we'd measure the mass of the balls, we'd measure the distance it fell, we'd time it and so forth, and then we ought to be able, whatever we come up with, we ought to be able to check it, repeat it, and verify it. Okay. Now, there are other methods of solving problems. I mentioned the democratic method. Okay, that's when you vote and the majority wins. I still believe it's a very good method for solving political problems. The second method is to appeal to higher authority. For example, what does some established authority have to say about it? Aristotle was thought to be a thinker for centuries. What did he say? And by appealing to higher authority, he said the heaviest one would hit first. But Galileo was different. Galileo used the scientific method. He took two balls of different masses, dropped them from the Tower of Pisa. That's the scientific method, an experiment, observing which one falls first, being able to repeat it and verify it. I will not drop the balls right now, but if you want to know what happens, do the scientific method. Get a stepladder in your garage, get somebody who is going to observe it, and find out. Okay, now there is a difference between a law and a theory. For example, if you drop this ball, that's the law of what? Gravity. You observe it. It's a relationship that's unvariable in the same conditions. I have dropped balls in Chile. I've dropped balls in Brazil. I've dropped balls in England. You've dropped things. You've dropped your keys. It always falls. Okay. This morning, probably most of you took advantage of the law of gravity. You took a shower. The water went down the drain. Aren't you glad it went down rather than up? That's a law. Okay, now, a theory is something different. A theory is an explanation as to why does the ball drop. Now, I know you can mathematically, by the law of gravity, you can mathematically predict the force between the ball and the earth. It's the product of the mass of the ball times the mass of the earth divided by the distance squared between the centers of the ball, and it's proportional to a constant. That's Newton's universal law of gravitation. But why does the ball drop? When you get into that type of question, you're talking about a theory. Okay? That particular thing, as I have never heard a good theory yet that explains exactly why the ball is attracted to the earth. Now, I want you to know that some theories are good and some theories are not good. Okay? I'm not going to blast today the theory of evolution because it's a theory. I'm going to blast it for some other reasons. Okay? Now, for example, I taught chemistry for many years in secular college. I spent almost the whole semester on the atomic theory. I told the students, if I took a piece of aluminum, I had a piece up here, if I tore that piece of aluminum in half, tore that in half, tore it in half, kept tearing it until I got the smallest particle of aluminum that has the properties of aluminum, that's known as a what? an atom, okay? I went on to further to say the reason why an atom of aluminum is different than, say, an atom of carbon is because the atom of aluminum has 13 protons, 13 neutrons, surrounded by 13 electrons. Now, I taught this for years. I have perhaps a lot of bad qualities, but one of the best qualities, or what I try to do, is be honest. I taught this for years. I taught that there was an atom. I taught there's protons, neutrons, electrons. I've never seen any of those. But yet, it's I believe, a good theory. If I was teaching chemistry again, it's the best explanation of why matter behaves the way it does. Okay, so theory is explaining why or how. Now, I want to say that origin questions cannot be solved by the scientific method. The reason you can't answer origin questions, like what is the origin of the universe, when was the universe formed, what is the earth, when was the earth formed, how was it formed, when did man appear, what did the first man look like, origin questions you can't answer scientifically. The reason is you can't observe origins. You can't experiment with origins. You can't verify origins. You can't repeat origins. Now, if I was to illustrate this, I think they'll understand by the mic, but supposing I asked somebody the question, when were you born? Is anybody willing to answer me when you were born? When were you born? March 25th, 1983. That's an origin question. How do you know? Okay. She said birth certificate. Did she solve that scientifically? No. What method did she use? What is sometimes called reliable history. I want to say, though, that doesn't always work. I taught a student in Wisconsin State University. His name was Sunday Iko. I said to Sunday, he was from Nigeria, I said, Sunday, how old are you? He said, I don't know. I asked him, when were you born? He said, I don't know, except it was on a Sunday. So they didn't keep birth certificates then. So what's another way to determine when, what is your name? Sheila? Sheila was born. What's another way? Who might you ask? Her parents. Which would you ask? The mother or the father? The mother. Why the mother? Is the father not honest? No. The father might have been away. Lots of babies were born during this past year where their fathers were in Iraq. Okay? So who should we ask? The mother. If her mother was here, your mother's not here, if I would ask her mother right now, when was Sheila born, she would give the same date. She would give a lot of details. If I ask her, how do you know? I've done this in audiences all over the country. If you ask, how do you know? She would say almost invariably, I was there. Okay? So when you want to answer origin questions, you ask the one who was there. Think about that for a while. Okay? Let's move on. We've showed you that this theory of evolution is not scientific. Now I'm going to show you some laws of science, established laws of science, that the theory of evolution contradicts. Number one, the law of biogenesis. The law of biogenesis says that life only comes from other life. Okay? The theory of evolution proposes that somehow life came from non-life. Small inorganic molecules combine to form amino acids, which eventually form proteins, which eventually form living cells. This spontaneous generation has never been observed. Thus, it is not scientific. Okay. I only know of 3 documented cases of non-living things coming to life. They are Pinocchio, Gingerbread Man, and Frosty the Snowman. And I want to tell you that most scientists, and I believe Mr. Young also would agree, that these reports are false. Okay? There are not 3 documented cases. There are no cases where inanimate objects have come to life. Sometimes people get the impression from the media that scientists are close to creating life. I want to say, if I came here today and I had 3 or 4 bricks, and I came to the first people I met and I was so excited, 3 or 4 bricks, I've almost completed the rebuilding of the Twin Towers in New York City. What would you think? Guy's cuckoo, right? Right? Now, I want to say that scientists have not come close at all, passing a spark of electricity through some methane and some ammonia and some water and some hydrogen to produce some simple amino acids is not as close to the complexity of a living cell as 3 or 4 bricks is to a skyscraper. Okay. So even if scientists could synthesize life, it would not be living matter spontaneously generating life. Second law, the theory of evolution contradicts, is the law of kinds. The law of kinds simply says life begets like. Okay? What does that mean? That means if you have a bean plant, you get what? Beans. You get an orange tree, you get what? Oranges. You breed rabbits, you get what? Rabbits, right? And when Sheila was born, was your daddy there? When the doctor came out to announce Sheila's birth, he didn't come out and say, "We're so happy, sir, you are now the proud father of a baby alligator." No. She was a human because her parents were humans. Okay? Humans beget humans. Uh-oh, another exception. St. Louis Post-Dispatch. Front page article, St. Louis Post-Dispatch. Papa was a dog, Mama a cat. The London pet shop owner who said he bred them now has 2 offspring, which he calls dats. Roy Tutt said he crossed a male Scotch Terrier with a female cat, and the offspring had dog's face and cat's fur and legs. Said a spokesman from the Regency Park Zoo, "I would have never thought it possible." My question is, how do you explain that? Or in German, was ist das? Or who dat? Okay? Now, the answer, I popped on the screen mistakenly just real quick, but the answer is not what theory you would propose, but the next day, buried in the St. Louis Post-Dispatch, a little bitty article. This picture was front page, showing the bias of the media. Now, little bitty article, buried about page 6 or 7. It says this: 2 furry animals that Roy Tutt offered as evidence of successfully mating a dog and a cat were nothing more than mongrel puppies, which cost me 5 shillings each. By spending the equivalent of $1.20, Tutt perplexed British animal experts for a few pounds, earned personal appearance interviews and photographs, but according to his handwritten confession, the whole business is a hoax. Why can't you breed a dog and a cat? Apparently the code information in the DNA molecules does not allow reproduction to take place. It is true there is variation in dogs. There are bulldogs, there are Scotties, there are collies, there are greyhounds, there are beggar dogs, there are Pekingese, there's dachshunds, and so forth. I do not deny the fact that within the dog kind there is variation. Same thing with cats. And I don't know much about cats, but there are Russian cats and Persian cats and so forth. Same thing with humans. There's great variation within this room. Now, I do not have a problem with variation. Some people term that microevolution, variation within a kind, small biological changes. By selectively breeding the tall dogs with the tall dogs, the white dogs with the white dogs, the spotted dogs with the spotted dogs, the long-haired dogs with the long-haired dogs, they have come up with a variety of dogs. Put them all together, though, and you get a mixture again. Okay, now, the theory of evolution, though, goes beyond that. The theory of evolution is not variation with a kind, but that one kind changed into another. That somehow, for example, a fish with fins evolved into an amphibian with legs. If a fish evolved with fins, evolved into an amphibian with legs, if it was scientific, we ought to observe some intermediate. We ought to be able to breed a fish with something to get the intermediate, half fin, half leg, and so forth. This has never been observed, never repeated, never verified. The questions will be taken after the session's over. Okay. Now, the second thing is that second law that the theory of evolution contradicts is the second law of thermodynamics. The second law of thermodynamics says that things or systems left to themselves will go to a condition of greater disorder. What we actually observe is if you throw a puzzle, the pieces of the puzzle up, there's a scattering. If you drop pickup sticks and they're in order, they go to disorder. Okay? You'd observe that all along. That's easily verified and repeated. But the theory of evolution says that somehow disordered particles evolve to arrange themselves in ordered life. That has never been observed, never repeated. It's like throwing the pieces of a puzzle up and having them come together to form the completed picture. Ladies and gentlemen, that is not scientific. That's not observable, repeatable, verifiable, or subject to experimentation. Let me ask you a question. Has a volcano that erupted ever laid out city streets, sewer systems, electrical lines, and so forth? It has. But boy, I'd be surprised. Okay. I'd like to know the verification of it. Okay. Has an earthquake ever produced a building across the street? Has a bomb, an explosion, ever produced order, such as the atomic bombs in Hiroshima or Nagasaki, or more recently, the bomb in Oklahoma City, the federal building there? Did that produce order? No. Observation, scientific observations show that no eruption, no earthquake, no volcanic eruption nor explosion has ever produced order. The idea that 13.5 billion years ago a kernel of energy exploded with a big bang to produce an ordered universe is a fairy tale. It's not scientific. It's never been observed, never been repeated, never been verified, and you can't perform an experiment. Thus, it's not scientific. Now, let's go into mathematical probabilities. How are we doing on time? I'm trying to see the timer. 7 minutes. Okay. Why is the study of mathematical probabilities so important? It's one of the strongest evidences against evolution is the mathematical improbability that highly complex systems, such as living systems, could have arisen by chance. The mathematical probabilities are quite interesting. Actually, they're quite reliable. If I had all of you, I guess there's probably 100 here, if I had you stand and flip a coin, what's the chance, if it's a random chance flipping, what's the chance of flipping a heads? 1 out of what? 2. Approximately 50 of you would have heads and 50 tails. What's the chance of flipping 2 heads in a row? Well, it's 1 and 2 times 2, 1 and 4. What's the chance of flipping 10 heads in a row? I mean, not a case where you flip it up and you look at it and determine which way you turn it, but I mean by random chance. It's 1 and 2 times 2, or 2 to the 10th power, 1 in 1,024. Combination lock. If you were in high school, you probably had a combination lock. What's the chance of somebody trying to break into your lock of coming up with the first number correct if you have a master lock? Well, you probably can't see it, but master lock has 40 numbers. Your chance is 1 out of 40. What's the chance of getting all three correct? Well, the chance is 1 in 64,000. 1 in 40 times 40 times 40. If a person was able to twirl the lock once a minute, different try once a minute, and did it 24 hours a day, it would take 44 days by probabilities to hit the right lock combination. By that time, hopefully the security would get them. Okay. Now the probability decreases as the number of components increase. I have here some flashcards. If I had held up 3 flashcards, what's the probability, if there was a predetermined number of these 3, what's the probability of you getting the number correct? Well, the chance of getting the first one correct is 1 out of what? 3. After that, the chance of getting the next number, 1 out of 2. The chance of getting the last number would be 1 out of 1, so the chance of getting the number correct is 1 out of 6. What's the chance of 10 flashcards in order? Well, it's 1 in what's called 10 factorial. 1 in 10 times 9 times 8 times 7. It's 1 in over 3 million. What's the chance of getting 100 flashcards in order? Well, it's 1 in 100 times 99 times 98 out of 0. It's 1 in 100 factorial, or the chance of 1 in a 10 to the 158th power, or 1 in a 1 followed by 158 zeros. Now, this could never happen, even that simple a thing, in the entire space-time universe. Any event with probabilities of less than 1 chance in 110 just won't occur. Somebody has estimated that there are 10 to the 80th particles in the universe. The oldest age I have heard for the age of the Earth, anybody ever guessed that, was 30 billion years. That would be 10 to the 18th second. I personally don't believe that because it hasn't been verified. Assuming each particle combined itself 1 trillion times a second, that would be 1 in a 10 to the 110th power. So if you have a probability less than 1 in 1/10 to the 110th, it just wouldn't occur in the universe. Now, what's the probability of life occurring by chance? The mathematical probability of atoms in a simple replicating proton has been estimated as 1 in 10 to the 450th power. The mathematical probability of a living cell existing by chance is 1 in a 10 to the 40,000th power. Let's break that down for the non-mathematicians. It's more likely for a tornado to pass through a junkyard to form a Boeing 747 than it is for the particles in a living cell to occur. It's more likely for billions of blind men, in fact, it's been calculated 10 to the 50th power blind men, to simultaneously solve Rubik's Cubes. That's more likely than life occurring by chance. I can't even solve it with my eyes open. Can you imagine even this group with their eyes open simultaneously solving it? Well, here we're talking about chance, not intelligent, but just blind men just rotating and all happen to come at the same time. The probability of life born by chance, it's more likely for an explosion in a print shop to produce an unabridged dictionary than it is for life to occur by chance. Mathematical probabilities show beyond doubt that whenever you see any ordered complexity in nature, such as is found in living systems, you can be sure that that complexity was designed, not by chance probability. Okay, the debate subject today was the following. Evolution is not scientific. I showed that even by the definition. Evolution is not observable. It's not subject to experimentation. It's not repeatable. It's not verifiable. The second topic was evolution contradicts scientific laws. I showed that by the law of biogenesis. Life comes from other life. The law of kinds. Things bring forth after its kind. Sometimes that's called the fixity of species. And the third law that it contradicts is the second law of thermo, where systems left to themselves go to a condition of greater disorder, randomness, or statistical Thermodynamics is a condition of greater probability. The third thing that I showed you is evolution is not mathematically probable. Thank you very much.